Hello Manghati, I am Taylor Swift, your narrator.
And I am Joe, a narrator too.
To begin with, imagine Sarah and John are a couple planning to start a family. Sarah's father had hemophilia, a rare X-linked recessive bleeding disorder, and Sarah is unsure if she is a carrier for the condition.
Meanwhile, John has no family history of hemophilia. Sarah and John want to understand the likelihood of passing on hemophilia to their future children and seek genetic counseling. The genetic counselor suggests using a pedigree analysis to determine the mode of inheritance and assess the risk of their children inheriting hemophilia.
But what is pedigree analysis? Pedigree analysis is the genetic representation that involves a construction of a family tree, known as pedigree, between new generation individuals and their ancestors, on which it shows the relationships between family members and their affected or unaffected status for a particular trait or condition.
Pedigree analysis can also be helpful in understanding the mode of inheritance, determining the probability of passing on a trait or disease to future generations, identifying carriers, and providing insights into genetic counseling and risk assessment.
Let's dig a little deeper in mastering the pedigree analysis with these symbols. If you already know the symbols on pedigree chart, you may skip to this timestamp. Here are the symbols: the male and female, the numbered male and female, the probands, the deceased, the affected, the carrier, the examined, the fraternal twins, the identical twins, and the adopted. And here are the other symbols: the unknown sex, lived one day, stillbirth, miscarriage, pregnancy, marriage, consanguineous marriage, extramarital mating, divorced, and no children.
To not lose track of the chart, Roman numerals are placed on the left side of the chart to indicate the number of generations, and the numbering of individuals is always done from left to right. A line between the male and female individual represents a marriage line. Then, a line of descent goes vertically downwards from a line of marriage to a sibling line. Furthermore, a line of an individual indicates offspring.
Now let us look at different types of pedigree analysis, depending upon the patterns of inheritance. A pedigree chart has 5 different types: autosomal dominant, autosomal recessive, X-linked dominant, X-linked recessive, and Y-linked inheritance. Autosomal dominant inheritance is a pattern of inheritance in which a single copy of the affected gene, located on one of the non-sex chromosomes, autosomes, is sufficient to cause the disorder. This means that if one parent carries the affected gene, there is a 50% chance that their offspring will inherit the disorder. An example of a disease is Huntington's disease, which is a progressive neurological disorder that typically develops in adulthood, causing movement, cognitive, and psychiatric symptoms. Autosomal recessive inheritance is a pattern of inheritance in which an individual must inherit 2 copies of an affected gene, one from each parent, to develop the disorder. Both parents are usually carriers of the affected gene, but they do not have the disorder themselves. Offspring of carrier parents have a 25% chance of inheriting the disorder. An example of a disease is cystic fibrosis, which is a disorder that affects the lungs, pancreas, and other organs, causing thick, sticky mucus to build up and block airways and ducts. X-linked dominant inheritance is a pattern of inheritance in which the affected gene is located on the X chromosome. Females have 2 X chromosomes, so they can inherit the gene from either parent, and males have 1 X chromosome, so they inherit the gene from their mother. The disorder is usually more severe in males because they do not have a second, normal X chromosome to compensate for the affected one. An example of a disease is Rett syndrome, which is a disorder that affects brain development and primarily affects females, causing developmental regression, loss of speech and motor function, and other symptoms. X-linked recessive inheritance is a pattern of inheritance in which the affected gene is located on the X chromosome. Females have 2 X chromosomes, so they can inherit the gene from one parent and be a carrier, But they typically do not have the disorder because they have a second, normal X chromosome to compensate for the affected one. Males only have one X chromosome, so if they inherit the gene from their mother, they will have the disorder. An example of a disease is hemophilia, which is a disorder that affects blood clotting, causing excessive bleeding and bruising, and primarily affects males. And finally, Y-linked inheritance is a pattern of inheritance in which the affected gene is located on the Y chromosome, which is only present in males. This means that the disorder is passed down from father to son in a straight line of male descendants. Females do not have a Y chromosome, so they cannot inherit or pass on Y-linked disorders. An example of a disease is male infertility, a disorder that affects male reproductive function, causing difficulties with sperm production or delivery. Now, we have discussed the beginning of pedigree analysis. There are different topics that involves pedigree analysis, for example, Punnett squares, but that is for next time. Now going back to Sarah and John's case, we now know that hemophilia is a hereditary illness, and is transmitted genetically from parents to their offspring. The X chromosome contains the hemophilia gene. In which case, we know that Sarah's father has the hemophilia disorder. He likely passed on the affected X chromosome to Sarah. So it's likely that Sarah is a carrier of hemophilia. John, on the other hand, has no family history of hemophilia, which means he is unlikely to be a carrier for the condition. When it comes to the likelihood of passing on hemophilia to their future children, it would depend on whether Sarah is a carrier or not. If Sarah is a carrier, there is a 50% chance that each of her children, both male and female, will inherit the affected X chromosome and be carriers like Sarah. If Sarah is not a carrier, their children will not inherit hemophilia since it is a recessive condition, and both parents need to carry the affected gene for it to be passed on to their children. So that's about it. Thank you for listening to this wonderful educational video about pedigree analysis.